Alright, in this video we are going to start talking about what a limit is. So we're going to look at the limit of a function. And the question is, what happens to the y values of the graph f of x equals x squared minus x plus 2, which I have graphed right here, as the x values get close to x equals 2. So the idea is we are going to make our x values get closer and closer and closer to 2. We're going to do that from both sides. And the question is, as we do that, as we follow along on our graph to get to that x value of 2 from both sides here, what does it appear as though my y values are going towards? So using an xy table, you'll notice that my x's are getting closer to 2 from the left side of 2 and also from the right side of 2. Okay, so I've kind of split this table into numbers less than 2 and then numbers greater than 2. But in each case, we're going to get closer and closer and closer to 2. The question is, what are our y values doing? Okay, so from a table, you can see that hopefully, as your x's are getting closer and closer to 2, the y values are getting closer and closer and closer to 4. If you look at your graph, that should also make sense. As we move our x's closer to 2 and follow our graph to an x coordinate of 2, the y values are approaching a value of 4. Okay. So what does this look like in terms of the notation? You're going to see the limit as LIM of f of x. So your function is going to be over here, whatever the function happens to be, as x approaches a. So underneath where it says limit, we're going to have an x with an arrow towards a number a, and then this is going to equal whatever the value of the limit is. Okay, so the way that you read this is the limit of f of x as x approaches a is equal to L. Alright, so here's another. We want to guess the value of the limit as x approaches 1 of x minus 1 over x squared minus 1. Okay, so we could do this without a graphing calculator. It's kind of the idea here. I'm going to use a graphing calculator so that we can see it, and so we can get our table a little bit better. But what we're going to do is we are going to make our x values approach 1. So we're going to make our x values get really close to 1. Okay, we want to get those as close as possible so that we can see a trend here. So I'm doing this again from the left side of 1. I'm starting at 0.5 and working towards 1. And then also from the right side of 1, starting at 1.5 and again working towards 1. I want to get these y values, and I want to hopefully see some trend with my y values, and whatever that trend is, that is our limit. Okay, so I've already kind of done this. I've graphed y equals x minus 1 over x squared minus 1. I'll zoom out so you can see what that looks like. And then what we've done here, or what I've done, is I have made a couple of separate tables to match those tables that you see on the notes. So starting at an x value of 0.5, what is the y value? Well, it's 0.6 repeating, so that y value would be 2/3. I'll just put 0.6 repeating. 0.9, I'm going to do about 4 decimal places here. So 0.5263. 0.5263. 0.99 is 0.5025. 0.99, 0.5003. And if we add another 9, 0.9999, 9, we got 4 of them, 0.5000. And if we went a little bit further, I could put a 3 here. And then again, I did this from the right side of 1. We have 0.4 at 1.5. At 1.1, 0.4762. At 1.01, 0.4975. Next one, 0.4998. And our last one, 0.4999. Okay, so again, the question is, as my x's approach 1, we're looking at both of these. They're getting closer and closer to 1 as we go down in those tables. What are our y values doing? And I hope that you see that you are approaching 1/2 from both the left and the right, which means the answer to this limit, the limit as x approaches 1 of x minus 1 over x squared minus 1 is equal to 1/2. At the end here, I want to consider a piecewise function where we have this graph x minus 1 over x squared minus 1 for everything other than x equals 1. And I didn't really address what was going on with x equals 1 here, but if you think about it, this function, if x were to equal 1, the bottom would be 0. So it's actually undefined at 1. And what we have going on here is an open circle at 1. So if we zoomed in here, and again, we've got some points plotted here. I'm going to delete these so that we don't see all those points. But at 1, the function is undefined, right? There's an open circle there at 1. So this piecewise function says, let's do x minus 1 over x squared minus 1 for every single x value other than 1. And then, if x is 1, then the y value is 2. Okay, so if x is 1, then the y value is 2, which means we have that point, part of our function. Now again, there's an open circle here, so that's totally fine. There can be a point above that if there's an open circle there. Okay, so for everything other than 1, we're using x minus 1 over x squared minus 1. But if x is 1, then the y value is 2, which means we have the coordinate point 1, 2. The question is, what is the limit? Okay, so again, as I'm approaching 1, what are my y values going towards? When you're dealing with a limit, it doesn't actually matter what's actually happening at that point. Okay, so I'm not really going to be concerned about what is actually happening at 1. What I'm concerned about and what a limit is as we get really close to 1, what does it appear as though our y value should be? So let's say that we have no idea what the actual y value is at 1. The question is, if I get really close to 1, does it look like the y value should be something? And the answer is yes, it looks like it should be 1/2. If I follow this graph from the left of 1 and also from the right of 1, it appears as though at 1 we should have a y value of 1/2. Again, we know that's not true because there's an open circle here and the actual y value is up here. But for answering limits, that doesn't matter. Okay, so the limit as x approaches 1 of this piecewise function is still 1/2. Okay, it doesn't change depending on what the actual y value is there. It simply is, what are you approaching? What does it look like the y value should be?